So just some opening thoughts. The greater Mediterranean Middle East region, which basically what we see on this map below, highly vulnerable for a number of reasons, including climate-related factors. Water insecurity in particular is of tremendous importance, physically, socially, and politically. Therefore, it's crucial to consider the context of vulnerability when we're examining the drivers and the effects of climate and weather extremes and climate change. I know a lot of climate scientists tend to look at vulnerability through a climate lens. I try to do that, but as well to be able to look at climate through a vulnerability lens, because I think that that's important. A better understanding of the complex relationship between all these variables that can affect vulnerability, overall vulnerability, can aid in decision-making and building of resilience through better policies. There are a number of ways that people and organizations are currently working to do this, working directly with stakeholders to provide and improve climate services. I don't know how many of you are familiar with the Intergovernmental Panel on Climate Change, but about every 6 or 7 years, these scientists globally from many countries get together and form working groups to try and put forth the state of the art of climate information. And what's interesting about the process is that before the document is actually published, it has to be signed off on all these countries, which means that that document in and of itself is conservative by virtue of the fact that a lot of these countries don't want anything more than conservative language when it comes to estimating climate in this document. But still, there's a lot of great information in it, and if you're interested in climate specifically, I encourage you to take a look at that. The Middle East and North Africa region is an emerging hotspot for worsening extreme heat, drought, and increasing aridity. Agriculture, where 70% is rain-fed, is highly exposed to changing climatic conditions. A warming of 0.2 of a degree Celsius per decade has been observed already in this region, and that was from 1960 to 1990. And since then, the region is warming at an even faster rate. So this is this exponential warming that we know about. Climate change might act as a threat multiplier to the security situation in some of these regions and countries by imposing additional pressures on already scarce resources and by reinforcing pre-existing threats connected to migration following forced displacement. So in the Eastern Mediterranean, aridification is obviously a concern. We talk about the greater region. We're talking about also some of the Middle Eastern countries as well, and Middle East, North Africa countries, which includes the countries along the southern border of the Mediterranean Sea, has already over the last several decades clearly experienced aridification and has for some time now been identified as a hotspot of future drying under climate change. This is from the IPCC and a host of literature. Over the Eastern Mediterranean, this drying signal is especially evident. And I've done some work on this when I was a graduate student, which kind of evolved into the Syria work that I did. And this is expected to potentially intensify according to the last several generations of these state-of-the-art global climate models. And additionally, we've seen displacement, human displacement. On top of this aridification, nearly all the countries on the eastern borders of the Mediterranean are experiencing the significant effects of human displacement that has occurred in the greater region, including the Middle East and the Sahel. The combined impacts of societal and environmental factors have led to the region experiencing acute water scarcity, low levels of resilience, social tensions, and conflict. So all this relates to the overall vulnerability. Sizable population growth in many countries has placed an untenable burden on groundwater, which has been a fundamental supplement to rainfall for irrigation, particularly during dry years, which has been declining rapidly due to overuse. Many of these populations are highly vulnerable to socioeconomic and geopolitical shocks, and climatic factors only serve to heighten that vulnerability, acting as what is often referred to as a threat multiplier, or an exacerbation of these threats, and to further reduce resilience. Reduced water availability can fuel public dissatisfaction that is already present on non-water related issues and can lead to reduced agricultural production and erosion of livelihoods and internal displacement. these impacts have serious implications for the social and political stability of the region. I talked about population increase. This is a several years old estimate, but the Earth is expected to have pass 8 billion people in the not too distant future, and possibly 9 billion by 2050. And you can see on the right that a lot of the places in this region have a very high rate of population growth. Additionally, this is a study from Familiarity 2014 and Nature Climate Change. It's looking at some of the world's major aquifers in the arid and semi-arid mid-latitudes that's derived from NASA GRACE satellites. And I don't know if you can see, but in the middle, the red is the Middle East. And you can see the decline even from 2002 to the present that is very significant. But this is a common theme. We're seeing a lot of the global aquifers that are declining. So you may have heard this phrase, this climate, water, food security nexus. There's some similar food, in this case, water, food, energy, climate nexus. But it's basically this theme that's become more in the public consciousness over the last 10 to 15 years, that's showing, that's really focusing on these direct links between all of these. Whereas I think maybe a little bit in the past, climate was kind of thought of separately than a lot of these other factors, but now people are starting to think about them in a more interdependent way, which is correct in my view. So these links between climate, water, and agriculture are fairly direct. Climate variability and change can strongly influence access to water and agricultural success, obviously. Links between climate and health, heat stress, malaria, etc., for instance, are more complex and indirect. And even more complex and indirect are the links between climate and migration, social unrest, and even conflict. Many factors influence civil unrest, including governance, economy, religion, access to food and water, healthcare, infrastructure, and others. And these all vary on different scales, both temporally and spatially. And that's key to remember, that not all these variables have these same spatial and time scales. We have to think about them differently, but then try to overlay them in a way that makes sense when we're comparing them. Therefore, monitoring of resilience and vulnerability, much less prediction of something like migration or conflict, is quite challenging. So just a couple of slides on a historical perspective of climate and society. It's happened before that the rise and fall of ancient civilizations has often been linked to climate variability and climate change. The Mayan Empire, about 4,000 years ago, from ancient Mesoamerica, flourished during a period of wetter than normal conditions over a couple of centuries, and then collapsed after an ensuing period of declining rainfall that lasted for 3 centuries. This climate change triggered a fragmentation of society and governance and an increase in warfare, and was followed by an extended drought and a population collapse. In the region that I'll be discussing today, the Akkadian Empire of ancient Mesopotamia, which is around the same period, about 4,000 years ago, this empire collapsed, and it was highly developed, and it was attributed to a sudden shift to more arid conditions. Similar collapses occurred in Egypt and in India during the same period. So the idea that the success or the failure of societies can be linked to climatic factors, not necessarily caused by climatic factors per se, but strongly linked to them, is not a modern idea. There's been a lot that's been written about this for older societies, including modern societies. So we also know that the world is experiencing a global refugee crisis now. Right now, we're witnessing the highest levels of forced displacement on record, around 80 million people, which is up from 65 million only 5 years ago. People around the world have been forced from home. Among these are 46 million internally displaced people. That's based on the end of 2019. This is from the United Nations High Commission on Refugees. Many of these do not have access to education, healthcare, employment, and freedom of movement. Syrians continue to be the largest forcibly displaced population in the world, with more than 13 million people at the end of 2019. That's more than half of the Syrian population. More than 6.6 million people have fled Syria, seeking safety in Lebanon, Turkey, Jordan, and beyond. In Lebanon, where more than 1 million Syrian refugees reside, there are no formal camps, and approximately 70% of these refugees live below the poverty line. In Jordan, there are nearly 700,000 Syrian refugees that are trapped in exile. Approximately 80% of these live outside camps, while more than 140,000 have found sanctuary at refugee camps, and most of these live below the poverty line as well. So obviously, a lot of what I'll be talking about today is, let's be honest, it's kind of gloom and doom, because there are a lot of significant challenges that we're going to be facing, that we're facing now, but that we're also going to be facing even more so in the future, that are related to climate and water security and the potential consequences of these. But I will try to end on a high note, at least talk about some of the things that we can do to confront these, and some of the organizations that are doing exactly that. The Arab Spring, for those of you who are not familiar, was a group of Arab countries, one at a time, that had uprisings. Syria was the last of the Arab Spring uprisings. This is a graphic from an editorial in the New York Times by Thomas Friedman. In the Syria case, in 2011, Syria, which was the last of the Arab Spring countries, collapsed into a prolonged, large-scale conflict, and they've been in conflict ever since. This occurred on the heels of 3 severe multi-year droughts, one in the 80s, one in the late 90s, and then again from 2007 to 2010. This last multi-year drought was the most severe in the observed record, and this had a catalytic effect. In this case, the Syria case, the causal chain is pretty clear. Existing acute vulnerability due to governance, overuse of groundwater, other poor governance and water insecurity issues, and so poor agricultural decisions that were made. And so when this drought happened, there was a massive agricultural collapse in what was called the breadbasket region in Syria. And because of that, there was a mass displacement of rural families to the urban areas. By mass displacement, we're talking about as many as 1.5 million people leaving these rural areas and going directly to the urban areas, which already had significant overcrowding and a lack of resources and employment. From a climate vulnerability perspective, the Syria case provides some prominent examples from which we can gain valuable insights. Climate change may act as a threat multiplier to the security situation in the region by imposing additional pressures on already scarce resources and by reinforcing pre-existing threats, which is important, connected to migration following forced displacement. In 2012, a briefer by the Center for Climate and Security highlighted the possible connections between climate change, drought, natural resource mismanagement, and instability in Syria, drawing on important research released in 2011 by NOAA and the United Nations Office for Disaster Risk Reduction. Part of the research that was drawn on was from Hurling et al. 2012, who had also already been examining this drying, this aridification of the greater Mediterranean region, which you can see in the map on the bottom left, and a time series that accompanies that map on the top left. And you can see from the red bars in the recent 20 or 30 years how significant that drying has been during those recent decades. This is from a paper that I wrote in 2012, looking at the trend in a slightly different way, using observations over a different period. But again, it makes this very strong case that this is widespread drying that we see all around the Mediterranean basin, and it does spread into the Eastern Mediterranean. And in this paper and in another paper, what we found when we did some attribution using the climate models and the observations, a large suite of climate models, and doing some signal to noise decomposition to look for the climate change signal that the models had in common, what we found was that the climate change signal was particularly significant over the Eastern Mediterranean. And one of the reasons for that is a lot of the natural variability in rainfall over Europe and over the Mediterranean is due to the influence of what's happening in the North Atlantic. Mm-hmm. And that influence starts to wane a little bit once you start to get to the Eastern Mediterranean. Mm-hmm. So it doesn't necessarily mean that the climate change signal is stronger in the Eastern Mediterranean, but rather less adulterated by the variability from the North Atlantic, if that makes any sense. Mm-hmm. So we wrote this paper I and my colleagues at Columbia, we wanted to look at the Syria case, mostly to see how unusual that drought was, that most recent drought, and how often those kinds of droughts had occurred that we knew of in the observed record, and whether or not it was just something that occurred occasionally and wasn't really, I mean, it was severe, but wasn't really that out of the ordinary for what typically happens in that place, or was it linked to this climate change signal in the Eastern Mediterranean that we had already found and knew existed. So what we found in this figure you can see in the top panel is for winter rainfall in the Eastern Mediterranean, the Fertile Crescent. What you basically have is a 6-month winter, which is when all the rain falls, and a 6-month summer when there's no rain. So it's just this one rainy season. And when you look at the November through April rainy season, and the blue line indicates the rainfall for each year going back to 1900, but better observations after 1930, you can see that there is a significant downward linear trend over that entire period. But more particularly, the occurrence of multi-year droughts, here defined as 3 or more consecutive years below the long-term normal, are shown in brown here. So we have, in this case, kind of in the late 1950s, this one severe episode, but then we have another severe episode in the 80s, another in the 90s, and then this most severe multi-year drought in the early 2000s. And so what we can see is, and again, this is not a 1,000-year record. It's not as much data as you would like to be able to say something significant about the frequency of occurrence of multi-year droughts. But empirically, you can see that 3 of these 4 most severe multi-year droughts have occurred within the last 30 years, which is what we would expect from the climate change signal in the rainfall. In the second panel, we're showing the temperature. This is the annual temperature. And one of the things that you can see in the kind of pinkish red section here is that for all of these years during this period, it's almost like it moved into a new regime, because none of these years, none of them were below the long-term normal for temperature. Every single year was above the long-term normal, which is not the case for the rainfall. So what we're seeing is a very strong nonlinear warming here, which is what we see in a lot of places in the Middle East. In the third panel, this is the Palmer Drought Severity Index, which combines rainfall and temperature as a means of kind of evaluating persistent drought. And you can see how well it lines up with what we see from the rainfall here and from the temperature here with these multi-year droughts. And then in the bottom panel, I'm showing the Syrian total population because we can think of total population as a proxy for the demand for water. The more people, the more water you're going to need. And you can see that in 1950, the population in Syria was on the order of 5 million people. And even before the conflict, the uprising in Syria, it had grown to nearly 25 million. That's an enormous increase in the population during a 60-year period, 60 to 70-year period. And you can see how that would put a much bigger strain on the demand for water, even in the absence of any kind of climate change. What we have here is converging trends that are really troubling. This is from a paper by Peter Glick in 2014, which shows the river discharge from in the Euphrates River coming from eastern Turkey. The Euphrates and the Tigris have their beginnings in the mountainous regions in eastern Turkey and then flow into Syria. So the reason I wanted to show this is because we shouldn't only think about the rain that falls in Syria or in the Eastern Mediterranean for that matter, because a lot of the irrigation relies on water that flows across the border from Turkey and is used for irrigation purposes. So they don't only rely on their rainfall that falls in that region proper, but also the water that flows in there in addition to groundwater. And you can see from 1990 to 2010 how this average annual discharge dropped dramatically. So not only were you facing a serious drought in Syria and the Eastern Mediterranean that was not really the case in Eastern Turkey, but then you also had a serious decline in the water that's coming in through the Tigris and the Euphrates. So one of the things that we wanted to do is to first use the observations that we had and to be able to do kind of like a 3-year running mean or low pass filter and to be able to say, if we regress this nonlinear climate change signal onto the observations, and then we remove that signal, and then we look at the distribution of the occurrence of these 3-year droughts, minus climate change, and then with the climate change that we know occurred. And particularly to be able to look at the dry end of the distribution. So what we're really trying to get at is how much more often do we have these kinds of really severe multi-year drought episodes when you include the climate change signal versus when you don't. And what we found is that there's a greater than 2-fold increase in these 3-year dry episodes because of the climate change influence. And we wanted to also, because the climate models actually have done a pretty good job of simulating the trends in this region, which is not the case everywhere. Sometimes the climate models don't do a good job of simulating those trends. And so we wanted to look at that and to be able to say, well, is there a big discrepancy between the observations and the models in terms of these 3-year droughts? And what we found was remarkably similar. In the bottom panel on the right, you find that there is also between a 2 and a 3-fold increase in these 3-year dry episodes because of the shift in the distribution due to climate change. So again, it's important to kind of keep in mind what's been happening in Syria and the vulnerability prior to this drought and prior to some of the other influences that we've seen from climate change. From the 70s to the 90s, agricultural policies promoted production of staple crops, leading to an increase in the number of groundwater wells and the use of inefficient and outdated irrigation methods. Syria had actually been very successful in its wheat production. It was exporting. They were a net exporter of wheat, winter wheat. And they had been successful at it for a number of decades prior to this drought. And when the drought happened and the agriculture collapsed and there was the internal displacement, they went immediately from being a net exporter of wheat to a net importer of wheat. And unfortunately, at that time, there was, I believe, a blight in Russia. And so the global price of wheat was one of its all-time highs. So Syria was forced to purchase wheat at a very high price when they had been accustomed to selling it. And this was one of the things that they had to, one of the adverse consequences of the economic ramifications of the drought. In addition, there was evidence of the drying of the Khabur River in northeast Syria. And we already knew that there were issues in the urban areas with the apartment prices in Damascus having more than doubled and wheat price and feed prices having doubled. And this was all coming together right before the uprising in Syria in March of 2011. So this is kind of an unfortunate picture of the agricultural collapse. This is farmers riding in their tractor in the drought-hit region of Osaka. And this is in June of 2010. So again, this is kind of in the height of the drought, several years into the drought and just before the uprising, 6 months later. So in addition to the time series that I've shown you, I wanted to also kind of show you the maps. On the top left, this is the rainfall climatology, the mean rainfall during winter from 1931 to 2008. And then the two blue lines are the Tigris and the Euphrates rivers, as you can see, flowing in from eastern Turkey and then progressing farther south. And what you can see, if you look at the dark crescent, this is where the Fertile Crescent gets its name. It's because of this crescent of rainfall that has allowed them to be successful in their agriculture for a very long time. In the top right, you can see the actual linear trend over that same period, the rainfall change from 1931 to 2008. And the reason I want to show this is because this is not just happening in Syria. This is a widespread regional drying over this long period of time that is influencing all of these countries, not just Syria. On the bottom, on the left, I'm showing the NASA GRACE product that's measuring the water at the surface and below the surface. And that record only started in 2002 to 2007. So I used that as a baseline and compared it to this really dry winter that was the driest winter in the middle of that drought. And you can see how much drier it is everywhere, pretty much in this box during that year. So this is not just the declining rainfall, but it's also the decline in the groundwater. And then on the bottom right, this is the normalized difference vegetation index for that same year. And you can see just how much the vegetation was affected in this region and in Syria in the north and in the northeast compared to the previous years. This year in particular was really really bad. After we published our paper, there was another paper that came out in 2015 by a colleague of mine, Ben Cook, who's at NASA, and they concluded using this tree ring record that stretches back, that's over the greater Mediterranean over the last 900 years, looking at drought variability. And what they found that for the Levant, the Eastern Mediterranean, that recent 15-year drought prior to 2015, with very high likelihood, was the driest comparable drought in that period over the last 900 years. So that's pretty strong evidence to indicate that the drying that we're seeing here is not natural. It is anthropogenic climate change. That these kinds of droughts with this kind of severity don't occur in the absence of climate change, or at least haven't occurred. So I also want to mention compounding effects. When I was looking at the news a couple of weeks ago, I saw that there had been a serious flood event. I think it lasted a week or two between Idlib and Aleppo in the northwest of Syria. And the reason that this was such a problem is because of the refugee camps that were there, because of the conflict, because of these displaced people that had been in part due to the drought. So harsh weather conditions have caused hardship and suffering for more than 1.5 million displaced people in northwest Syria. A lot of these have lost their temporary homes with heavy rains, flooding, and snow as winter has set in. CARE's, an NGO, CARE, Swiss NGO, the country director in Turkey, said that displacement has yet again caused misery for thousands of vulnerable populations in the northwest. With winter setting in, rain and flooding has destroyed the homes of tens of thousands of people who've already been displaced. So I felt it was important to show this because we tend to think about sometimes, or some people do, we look at climate change, we look at droughts, and we think, okay, that's all we need to think about. But also you have flood events. So it kind of gets back to this theme of we really need to look at all of the time scales and all of the spatial scales, because this was a more localized flooding event, but it still had dire consequences, and it was made more, the consequences were made more severe because of the existing vulnerability. So also I was asked to kind of weigh in on whether there was any kind of climate change evidence in Afghanistan, which is a neighbor, obviously. And as with the rest of the Middle East, Afghanistan is getting much warmer and is expected to continue to do so. But there have also been more recently, in the last 10 to 15 years, declining precipitation trends, though these are less significant. But the overall aridity has been increasing. And there's a lot of problems with conflict and with, I think it's, let me get this wrong, opium being grown there. But it's a really bad situation. According to the World Food Program, droughts and other disasters have limited the productivity of the agricultural sector. And this is a common theme, again, with all of these countries. Afghanistan currently facing a severe drought, the worst in over a decade, and it's affecting 20 of the country's 34 provinces, mostly those to the north and the west. Over half of the country's population lives below the poverty line. They have rampant food insecurity, and there are concerns about corruption, transparency, and illegal industry further exacerbate this situation. So the influence of recurring and persistent droughts is made worse by climate change and has severely exacerbated these existing vulnerabilities. In Iran, over the past decade, Iran's water crisis has morphed into a new paradigm with its impacts now visible in the daily lives of millions of people. This is from this project from Stanford, a national adaptation plan for water scarcity in Iran. Iran also has a growing population. The per capita food demand has gone up. There's been an increase in the need for water-intensive crops due to increase in per capita income. There's been insufficient job creation. There's been poor governance and poor water resource management. And in addition to all of this, again, an increase in average temperature and a decrease in the average precipitation that are both likely due to climate change. Lake Urmia in northern Iran, this is the middle panel on the left. 20 years ago, it ranked as the 6th largest saltwater lake in the world and the largest in the Middle East. And then this is a picture from 2011, which is only 13 years later. And you can see how much this lake has shrunk. And a lot of that is due to overuse of groundwater in the north of Iran that has basically sucked some of this water underground. And this is related to decades of poor water management, aggressive agricultural policies, and drought. In the United Arab Emirates, Saudi Arabia and the UAE, these are wealthy countries that can afford to desalinate, basically take salty water out of the Persian Gulf or out of the Red Sea and remove the salt and have potable water out of it. So they're able to afford what has been expensive and energy intensive to do that. But still, they're highly vulnerable to food imports volatility due to climate factors from the countries that they buy foods from. So they're certainly not immune to the climate variability that's occurring in other regions from which they receive their food supplies. This is from a UN-backed report, The State of Desalination and Brine Production, a Global Outlook. The production of brine, basically the removal of the salt from the water, is environmentally not good. And what happens a lot of the time, particularly, this is a picture of one of the large desalination plants in Israel, is that Israel, who also does a lot of desalination, dumps their brine back into the Mediterranean Sea, which has bad environmental consequences for the Mediterranean Sea along their border, but also as it migrates along the coast for some of the other countries along the Eastern Mediterranean. I did some work in Yemen during my postdoc. Yemen's one of the poorest nations in the Arab region and one of the most food insecure nations in the world. And they have been in a conflict with Saudi Arabia for some time now, and it's had really bad consequences for the people of Yemen. Yemen has seen conflict arise from land and water disputes often in the past, but they have this ongoing civil war now that has worsened the already poor living conditions. Yemen is acutely vulnerable due to many factors that we've already discussed, and they have existing hydrologic insecurity, predominantly from unsustainable groundwater use, population growth, poor governance, cot production, and other factors. So there is quite literally a humanitarian catastrophe that's unfolding in Yemen, as millions have fled their homes. A lot of people from Yemen have basically taken the life risk of getting in a boat and trying to get over to Ethiopia and to try and work their way up to the Mediterranean and get into Europe. So that's a very poor situation that's going on there. And for the Yemen people, they don't really have anywhere to go other than to make that trip. Syrians at least had the opportunity to go into Turkey or Lebanon or Jordan, or to continue through Turkey and to go into Europe and that kind of thing. But for Yemen, they don't have that opportunity. So I want to go back and talk a little bit more about Eastern Mediterranean water security. Water cooperation has always been vital to promoting effective water management policies across borders and to building trust and confidence in relationships between Jordan and Israel and Palestine and Lebanon and all of these countries that rely on the Jordan River, for instance, for their water. It's still a critical issue and one that has been negatively impacted by recent deterioration in Israel's relationship with Jordan and the Palestinian Authority. These events have exerted greater pressure on water resource availability in the region. The combination of natural aridity, mismanagement of existing resources, climate change, influx of refugees, and now a global pandemic is severely taxing the region's ability to meet even daily domestic water requirements. Modestly sized Jordan River Basin provides water access to Israel, Jordan, and the Palestinian territories, as well as Lebanon and Syria, which is stretching this resource to its limits and beyond. Water has been touted as a means of bringing some hope for peace in the region, but has also generated warnings by some global leaders of potential water wars in the future. Many arid and semi-arid regions include agrarian societies, which are highly vulnerable, not least of which is increasing water stress. Recent events have exerted greater pressure on water resource availability in Jordan, as in the greater Middle East. The combination of aridity, mismanagement, climate change, refugees, etc. The modestly sized, I already said that. Jordan and Israel are two riparian societies, most dependent on the Jordan River as a source of water. Jordan is one of the most water-stressed nations in the world, according to WRI, relying heavily on its aquifers for nearly 2/3 of its water. And these aquifers have been declining at a rapid rate, an unsustainable rate, surely. Some Jordanian scientists predict that the aquifers will run dry in the coming decades, if not sooner. Jordan is landlocked and does not share the rich oil and gas resources that many of its neighbors enjoy. It's therefore limited in its ability to utilize large-scale desalination projects to alleviate water shortages, an advantage that Israel has successfully employed. Due to the increasing demand for water, the Jordanian government has, out of necessity, drilled more wells for the last 50 years, further depleting its groundwater, again at an unsustainable rate. And this over-reliance on groundwater is particularly alarming in the face of increasing aridity. Population has increased significantly due to natural birth rate and the large influx of refugees, many from Syria. This is from two things that I read recently that I thought were compelling. Emerging security threats in the Middle East, the impact of climate change and globalization, and Don't Politicize Water, a brief from Foreign Policy in September of last year. Opportunities for expanding peace in the Middle East have been rare over the last few decades. Certainly Jordan and Israel have had their differences, but they should not come with the dismantling of institutions that have provided the foundation for cooperation. With the withering of the bilateral relations, water cooperation has become politicized and vulnerable. Water-stressed Jordan still depends on Israel to secure water allocated to it by the 1994 peace treaty. And deteriorating ties with Israel not only put regional stability at risk, but also harm Jordan's water security. So I at least wanted to talk a little bit about climate science challenges. From a climate science perspective, certainly there are significant challenges that exist with respect to our knowledge. One example is a more thorough understanding of how climate variability has manifested in the past on different timescales. If we have a better idea of what natural variability has looked like in the past, then we can say more about, how unusual natural variability or how the variability is changing now. But we need that baseline. These stressors at differing timescales can also overlap, both at regional and national levels. In addition to filling the gaps in our understanding of climate science, we need an improved understanding of the complex relationship between social science and the nexus of climate, water security, and human displacement in order to have better decision-making. And this is a tall order. This is not easy to be able to do that. This approach recognizes, however, that displaced peoples are not homogeneous and will have varying climate service needs according to their responsibilities and based on livelihoods. There are overarching challenges in streamlining improvements of science, both physical science and social science, into the services and policies at the regional and national levels. To do so, well-defined, sustainable climate services are needed from both a climate science and governance perspective. These services largely do not exist, especially for displacement-specific settings. Now, this is climate services is kind of still a nascent idea, but it is really picking up momentum. And I guess I should define what I mean when I say climate services. We can think about climate science as providing climate information, climate analysis, climate monitoring, these kinds of things. And then at the end of the other end of the spectrum, you have decision makers that are presumably using climate information. But in between, you have to have the translation and the dissemination of that information, which has always been the biggest hurdle. The communication of climate science in a way to be able to better inform decision making is of paramount importance. And it's something that I've been trying to focus on in my work, but many others are focusing on that now too. So we have to think about not just producing climate products that we can, but rather making sure that the climate products that we produce are well informed through stakeholder engagement and through close examination of vulnerability. So our primary challenge is to facilitate how appropriate climate information can be used, in addition to the identification of the climate products that are available. So just some closing thoughts. There are obviously significant challenges to address. Governance and resource management are key factors for building of resilience. There are significant gains to be made through appropriate consideration of how climatic influences can interact. And again, interact in different spatial and temporal scales, but also interact with other variables and combine to impact people's health and well-being, and through convening to address these considerations. Climate's influence can vary dramatically based on the underlying vulnerability. That's really important to always keep in mind. If you have one place that's more vulnerable than another place, and they both have the same drought, then the place that's more vulnerable is going to have more impacts because of that drought. More research is obviously necessary to better evaluate and characterize the relationship between climatic and socioeconomic, geopolitical, and other variables, in particular with regard to the methodologies that we use to evaluate these complex interdependent relationships. And a lot of these methodologies are just now being formed. There's a lot of experimentation that's going on with trying to relate these variables through different methodologies. And so that's something that is really there's a lot of work that's going on in the research community that's related to that. Although every nation in this greater region is different, there are important parallels that can be drawn. We should, however, be cautious about extrapolating outcomes that occur in one place to others. What I mean by that is, I've been asked many times, about my Syria work. They said, well, where do you expect the next conflict to break out like this? And I say, well, we have to pump the brakes there because every place is different. We have to consider the underlying vulnerability and all of the factors that come together in a kind of an independent way. But that doesn't mean there aren't things that we can take from these case studies and be able to apply them, but you have to do it carefully. I like this quote at the bottom. This is from the former president of Liberia, Ellen Johnson Sirleaf. In reforming management of our high-value natural resources, we are finding our way along the path from conflict to peace and sustainable development. We are not alone on this path. And she won the Nobel Peace Prize. So again, there are some reasons for optimism. This is very sobering material. There are a lot of serious challenges that we have to work on in the global community, not just in the Middle East or in the Eastern Mediterranean, but we can all, hopefully, these countries can come together to support each other because it's in everyone's best interest. Certainly, we can see this in the refugee crisis example. What happens in one place doesn't always stay in that place. So I wanted to call out at least some of these excellent organizations that are dedicated to building resilience and stronger institutions and to conducting vital research. The Environmental Peacebuilding Association is one, the Berghoff Foundation, Stockholm International Water Institute, the Peace Research Institute in Oslo, the Advanced Consortium on Cooperation, Conflict, and Complexity at Columbia, the Potsdam Institute for Climate Impact Research. Again, this is only a smattering, but it kind of gives you a flavor, if you're not familiar with this, to see that there's a lot of really good work that's happening, and we're not always aware of it. So even though there are these challenges, there's a lot of people, there are a lot of really smart, capable people that are working to try and move this work forward and to build resilience and to improve institutions and build better governance. So I hope I didn't go over by too far. but I'll be happy to have any questions that you have. Thanks.
Great, thank you very much. We certainly have time for questions. So I think we can start with any questions either in the chat function, which I can read out if folks can't see it, or if people would like to unmute themselves by raising their hand, and then I can try to call on them from there. Or if I can't see you and it doesn't seem like Colin mentioned he couldn't see the chat either, just speak up as well.
Can I ask a question, Kara?
Yes, please.
Hi, Colin. If you can't see who this is Derek Martin. Ben, that was a fantastic talk. Thank you, first of all. I'm a river system geomorphologist / hydrologist, and so I was glad when you mentioned the flood that impacted the Syrian refugee camps. And so I was curious that in your drought research, you know, earlier in the presentation, you showed the graphs from your paper in the Journal of the National Academies that showed precipitation trends over the past about 100 years. And that you had identified those 4 of the greatest drought periods you'd seen, you know, over those 100 or so years. Mm-hmm. But, you know, I also noticed that during that same time period where you identified those 3 or 4 drought years, there was also 3 or 4 of the largest precipitation years as well. And so what I'm wondering is that in your research, you know, have you also seen some of the impacts of these major flood years on similar things like crop production and food availability and that sort of thing? Because, you know, that's something we're experiencing here in America's breadbasket with these major flood years following droughts.
Yeah, thank you for that comment. And that's absolutely true. Most of my research has come at it from a drought point of view. So that's just kind of my paradigm, but you're certainly right. And it's one of the reasons why I wanted to put in that example of these flood events in the refugee camps last time. I have a colleague who's, I'll say, a flood guy, and he does a lot of flood modeling and that kind of thing. So I've worked closely with him on some projects, and certainly you're right. It's not all about drought. It's certainly very much about flood events, especially for agriculture. And one of the things that I didn't really talk about was some of my work that I've been doing in the Sahel, but also in Bangladesh, that really starts to examine in a particular year during the rainy season. We have a tendency to think about what was the average rainfall that fell during that rainy season, right? And think about that. But really, from an agriculture point of view, there are a lot of bad things that can happen, even in a year that has, quote, normal total rainfall, because of these days where you have really extreme flash flooding, or when you have, you know, maybe a 20-day period in the height of the monsoon when it didn't rain and it was supposed to. So it's this kind of more chaotic, high frequency events that are really important also. And so I'm glad you brought that up. Thank you.
Yeah, thanks a lot, Colin.
Great. Any other questions? I see a hand up, Saskia.
Yeah, Colin, I was wondering if you could give the grad students advice about some of your analysis, which programs you used, or especially the maps that look like they were performed in R. I know you said that you've used MATLAB before. What advice do you have for that kind of spatial analysis with climate?
Yeah, I guess it's because of the fact that I changed careers. You know, I basically learned to use MATLAB and then didn't learn anything else. So I don't really have any coding skill in R or you know, some of the other programming languages. I did a little bit of MATLAB when I was doing my undergraduate work, but that was so long ago. I mean, did I say MATLAB? I meant Fortran. A long time ago when I was doing my undergraduate, but I don't remember anything along those lines. So I'm not really a good example for your graduate students in that regard. I think everybody should learn to program in at least 2 or 3 languages if possible. But for me, pretty much everything that I've ever done, I've been able to do in MATLAB. And so I've just kind of stuck with that.
Great, thank you.
Sure.
Any other questions?
I'll ask a quick question. Great talk, Colin. I was trying to listen, we have kids at home, but I'm really interested in the climate attribution piece.
Okay.
And, you know, it's an area I think is really interesting. What are your thoughts on like emerging methodologies? It seems really hard to make that attribution. Do you have any advice in working in that realm? You know?
Well, first of all, let me clarify whether you mean attribution of like climate change versus climate variability, or attribution of climate kind of among other variables.
I guess the easiest to me seems attribution of climate before you get into the climate change piece.
Yeah. Yeah. There are some good papers, and I probably should have listed some of them, that have come out in the last 5 or 6 years that are, some of them are mostly about climate and migration. Some of them are more about climate and conflict and these kinds of things. But they've really gone about it in different ways, very starkly different ways, using different, statistical methods and the kind of variables that they look for to look for relationships and these kinds of things. And so I went to an event, and this was maybe 4 or 5 years ago now, where it was talking about some of the government agencies that have government funding to try and predict conflict. And one of the things that struck me was none of them were similar. Like the group from the CIA that had started to try to predict that, they were only looking at slow moving, low frequency variables. And they only had like 3 or 4 variables, and they just chose those variables because that was their a priori assumption about the things that were important and that were likely to be important in a lot of different places. But again, that kind of gets back to this idea that what it completely leaves out is some of these more high frequency events that are often very important, right? But then there might be another example where they took 100 countries and they picked out 30 variables that could be relevant, and they did this huge regression, and then they came up with these regression coefficients, and then they evaluated each of the countries. But one of the things that struck me was that the regression coefficients that they got from looking at 100 countries didn't actually apply to any country. And this is kind of that example that I was saying before about you have to be very careful about looking at a country and looking at its unique relationships between variables, because these relationships do change very much from one country to another in terms of the variables that are most important toward evaluating vulnerability or migration, these other kinds of things. And so there's still a lot, I feel, that we have to unravel about trying to come up with a way that makes sense. I mean, I guess you kind of have to use a top-down approach and a bottom-up approach to be able, and to use case studies, also regression, to be able to say things, to say more about these relationships. But I'm not going to pretend that it's easy, and I certainly don't have those answers. And I think that that's something that's very much still being developed. And even the papers that I mentioned before, where the ones that have made attempts to do this, they've been they're very much praised, and then they're also very much vilified. It's very much, it's like either you really like that approach or you hate it, so there's a lot still left to be done, I think. And so it's kind of hard to compare those. I'm not sure if that answered your question.
No, I feel the exact same way, but it's nice to have your viewpoint.
Excellent. Anyone else for questions? Andrew Bagwell, I see your hand.
Yeah, that's me. Still getting used to these functions.
Mm-hmm.
Hi, I remember early in your presentation, you showed a map of some of the major aquifers.
Mhm.
I think that the one that was labeled Middle East looked like it had a sharp rise in the past couple years. Am I mistaken? If that's the case, how did that happen?
That's a good question. Let's go back and have a look.
Making you go all the way back.
I know. So difficult. Okay. Getting close, getting close. Too many slides. Okay, here we go. Yeah, that's really interesting. I hadn't actually noticed it until you said that about that kind of hook at the end. Generally, you would think about aquifer recharge needing to really take some time. It's not something that would happen in a very short period of time. Even if you had a really wet, seriously wet year, it would still not show up that sharply, I wouldn't think, in the aquifer recharge that quickly. I mean, that's a pretty big shift in what looks like it's a 1 or even a 2-year period. So that's a great question.
Okay, so it wasn't part of your work, I guess. You're taking it from the jet.
Yeah, this is from a Nature paper by Familietti.
All right, thanks.
But also, I will point out too that this is I showed a figure that I had used NASA GRACE data, and this is not just aquifers. This is also surface water, because this NASA satellite can't differentiate very well between water at the surface and water that is below the surface. So then that says to me that possibly what you could see is not only aquifer recharge in that blip there at the end, but also could be some serious ponding of water on the surface that's also contributing to that. Although, again, that would be something that you would think would go away in pretty short order. So I'm kind of grasping at straws.
Very interesting. Excellent. Any other questions? No. Okay. Before we wrap up, I would love to just ask Colin, what are your next steps? I'm always very curious to have an opportunity to talk to colleagues about their present research, but also what are your plans for future research and how you see things changing as climate and particularly things like global health has shifted with things like COVID as well.
One of the things that I've been more focused on the last year and a half, I guess, is I've been doing some work in Bangladesh and some in Niger, et cetera. So I wasn't really working. I didn't have funding to work on the Eastern Mediterranean so much. But I went to this workshop in Amman, Jordan, 18 months ago, and I met some really cool people there. And one of them is this group called Eco Peace Middle East. And they're really working hard to try and build an argument so that Jordan and Israel can have better water policy and better water cooperation. And one of the things that they were pitching was that Jordan has this real opportunity for solar. I mean, it's basically desert in the east, and so they could set up huge solar arrays and produce a lot of solar power, and that they would like to be able to trade that for water with Israel, because basically Israel is charging them a high price for water right now. Israel can, so they do. So, but there's not a lot of political incentive from the Israel side to do that. So anyway, kind of coming out of that, I went back and some colleagues and I guess this was March of last year, we submitted a NASA proposal to kind of go back and look at climate services, particularly in displaced settings in the Eastern Mediterranean. So to really look at these places, these camps, these refugee camps, even going up into Turkey, and to be able to do some surveys and then to do some more rigorous analysis of the information that would most help the people on the ground, right? What are the climate services and the climate information that we could provide that is maybe different than what we thought before, to be able to say, yes, through this conversation with the stakeholder, here's what we would really like to have, and that would help us make a decision, and to be able to sit down with them and say, okay, well, we can provide you a full probability distribution of some event with some error bars, but at what threshold do you make that decision? There's some paralysis on the stakeholder side that comes from that, and say, okay, this is all great information, but I don't know whether I should release these funds or take this step in action based on a 37% probability or a 42% probability, or not at all, right? So these are the kind of things that I've been thinking about trying to work toward, that's really related to these climate services aspects that I spoke about before.
Excellent, thank you. Great. And just to double check, I'll check the list to see if anybody else has any other questions.
I have one quick comment about, I guess, northern India or India in general and their sort of water practices. I think it's really interesting. I've seen a lot of people there use kind of traditional methods for like groundwater detection. It's called water dowsing. Not very scientific from what I've read. And so I think it's really interesting that there's kind of a presence of unsustainable bore well drilling there, and that they, large numbers of farms there that need groundwater and very much depleting the aquifer. So I think it's kind of interesting thinking about like kind of a cultural aspect of water practices where, certain places might not really favor or use as much more of the modern, more sustainable methods for groundwater harvesting, I suppose. So I was just kind of curious if there was anything that you knew of like that in Syria, where people use more traditional methods for groundwater, like bore well drilling or aquifer depletion or anything like that. Less of a question, more of just a comment of, I think that it's kind of interesting that, different parts of the world kind of use different methods and some of them aren't always sustainable. So.
Yeah, that's a great point. Thank you for raising that. There are certainly a lot of these places, these agrarian societies, that very much cling to, what they've done culturally, historically, right? And so there's always some reluctance, even if there's a better method available, to switch over, right, from some irrigation practice that they've been using for a very long time, because that's what they've known, that's what they've been taught, it's been handed down. And the same thing, with the well drilling. In the Syria case, the government had they knew that there was a problem and that they had basically made it illegal to dig any more wells, but that was completely unenforceable. And when you need water and the only access that you might have to water is to dig a well, then you're going to dig a well. So that's certainly something that another challenge that you have to overcome in a lot of these places. In the Yemen case, I don't know if this is what you were mentioning, but they grow a lot of cotton, which is very water intensive, and they use flood irrigation. So even the water that they do have access to, they're mismanaging it in a pretty severe way. There's really, most of it's evaporating and it's not actually going into the production of the agriculture anyway. And, it's a sad situation.
Excellent. All right. Any other final questions? No? Okay. Well, on behalf of our department, Colin, thank you so much for taking the time and presenting such a wonderful and timely topic. We appreciate your time, and I'd like to thank everyone for joining us, and thank Lauren Anderson for the technical support. So thank you so much. Let me find my little clap function. I'm not as... There we go. Okay, so wonderful talk, and thank you for your time.
Okay, thank you.